U. So if I give you, let's say U at x is equal to 3x cubed minus 5x plus 2. And I can ask, find the conservative force associated with that. What do? We derive. We do the opposite process. Yes, derive? Yes, derive? Or what is the formula for conservative force? Check there, what is the formula for conservative force? Negative the derivative of U with respect to dx. So if you don't put the negative, will be incorrect because we are looking for the conservative force. So negative du. Right, now 10 minutes. Okay, so what do we do here? We derive. So what will be my potential energy associated with this force? Will be negative 6x plus, or negative 5. That's it. This will be given in joules. Actually, this is U or this is F. F equal to negative 6x minus 5. Good.
Yes.
What about if I ask now, having this function of force, tell me at what point is the equilibrium point? What is the meaning of equilibrium in physics? This object is in equilibrium. The force is zero. It's the moving. The acceleration is zero. Or moving at constant velocity, right? So that's the meaning of equilibrium in physics. What is the law of equilibrium in physics? The Newton's first law. That is equilibrium. Law of equilibrium. So if I ask, what is the equilibrium point? What do? You set the force equal to zero. The force equal to zero give you the equilibrium point. When I find x, x will be the equilibrium point.
Isn't it plus? It's plus 5, right?
This is negative outside, so will be plus, but now it's negative
It should be plus.
6x minus 5. When I distribute it, will be plus. Right? So this will be certainly the same than negative 6x plus 5. Correct? But now, if I ask what is the equilibrium point, you made the force equal to 0. So this will be negative 6x plus 5. And we get x. And that will be where we have equilibrium point. X is equal to so will be 5 over x, 6, right? This will be my equilibrium point. That will be my equilibrium point. At 5 over 6, we will have an equilibrium point. Now, if we have, this is just to understand, if we have this, if this is my potential energy function, if it's like this, the equilibrium point, where will be the equilibrium point? So this is U versus X. Where do you think that will be the equilibrium point? When the derivative, no, that's not the force, this is the potential energy. So when the derivative of this is equal to 0, at the top point, at the maximum, at the maximum, which is the critical point. So in math, the point of equilibrium will be where is the critical point. Now, if this is a maximum, we will have unstable equilibrium. So at the maximum, if this is maximum, will be unstable equilibrium. If it's a minimum, we will have stable equilibrium. In other words, if we have this, look at this path. Where do you think that will be the region of stable equilibrium? At the bottom. So, where the potential energy is minimum? At the top or at the bottom? Can you see that this region is of stable equilibrium? When it's at the top, maybe it's in equilibrium as well, but it's unstable. Easily. From where will go this, if I just take this slightly away from here, from where, I mean, will come this unstabilized? Better, in this one or in this one? You see that I release, it's unstable. On this one, it's stable. So from here, the word stable and unstable, there are two regions where we can have equilibrium. On the top and the bottom. When you have something like this, usually at the minimum, we will have the equilibrium point. On the top, we will have unstable. This is stable and unstable equilibrium. Good. Extra to know. Okay, so if I ask where the point of equilibrium, you just can find that is a 5/6.
I have a question. The equilibrium point is not when the net force equals 0. It
Yes.
is only the force.
When the force is equal to 0, this is the only force. We are assuming that this is the only force, right? So, and that is force is conservative. So if I ask, at what point is the equilibrium point, you just need to find where the derivative
So
of.
if we had other conservative force, we have to sum them together and equal.
If we have many forces, and I ask what is the equilibrium, or the equilibrium, but you need to add all forces and get when will be the net force equal to 0. But this is the only force. If this is the only force in the problem, I'm asking for the equilibrium point of that force. All right, good. Knowing that, this is just the definition. So if you go to the study guide, in the study guide, we go now to the second section. We finished with the first section. We go to the second section, where it said potential energy. So this topic is related to all types of potential energy in mechanics. And for example, I give the following. Question number 1.